Electric drives essentially are things that help in optimizing the performance of the motors, or in general, any electromechanical system's performance. In fact, drives do that, and drives can be in general mechanical and electrical both. But electrical drives have significant advantages over mechanical drives, better control, more accuracy, and so on. So they are becoming a lot more popular. Okay. That's what this slide tells you. Now, the trend right now is to include motor in the definition of the drive. Okay, which is fine. The entire system is known as a drive in today's world, including the motor. Motor essentially needs either AC voltage or DC voltage, depending on its nature. And if it is AC voltage, it can be three-phase or single-phase. In case of DC motors, it is the voltage input that has to be controlled properly and in a continuous manner to get the best out of the motor. In case of AC motors, it can be voltage as well as the frequency of the signal coming in that can be controlled. Methods, of course, are several. Silicon controlled rectifier is one very popular method, which essentially helps in controlling the magnitude of the voltage being applied to the input of the motor. I have shown this schematic in the previous lecture also. Essentially, you keep sensing the output of the motor, torque, speed, power, and even current going in if necessary, voltage being applied if necessary. It all depends. And that sensing unit keeps feeding the info back to the power modulator that controls the input to the motor. Source's output will not change. That is fixed in a given situation. But power modulator does all the variations in a dynamic manner. Control unit has an input command which can be manually used to override everything else if necessary. I was showing you this one last time, where input is a solar cell, in fact, an array of solar cells. And because solar cells produce DC output, we have to put an inverter, assuming that we are talking about an AC motor here. And then electric motor runs the system. This is an open-ended situation. No correction is being made. So you'll get what you'll get. A lot of factories operate that way to save money. They manually control motors input rather than doing it automatically. In small settings, it is okay. But in big factories, it is simply not desirable. Here are two motors cascaded and drives are on the top. You don't see anything except controls. That's it. Single motor is also shown here. Again, a drive on top. Most of the time, drive will keep doing things automatically. You don't have to worry about anything. If there is a red light on or a warning signal, then you have to do manual intervention, for which there are inputs available. Source obviously can be an AC voltage or DC voltage. In case of AC source, as I said already, it can be single phase or three phase. Power modulator or power electronic converter is the interface between source and motor that we saw in the block diagram. Control unit, as I told you, controls the performance of the motor, speed, torque, etc. And it is done through adjusting frequency, voltage, and current of the electric input to the motor. The ideal goal is to be able to control any kind of motor with any kind of electric input. That is how we try to design the drive. Okay, most of this is self-explanatory. Advantages: electric drives can be cheaper, they can have easier control. Remote control is possible through wireless technologies. You don't have to be physically on the site all the time. Installation is more flexible. Maintenance is easier and cheaper. Generally, they are smaller in size than mechanical drives, and efficiency is also higher, in general at least. More advantage, sorry, these are disadvantages. Accident chances are higher because you are dealing with electricity. And if by chance electricity fails, then everything stops. That is a disadvantage. And if you are operating in places where electricity supply is not there, then obviously this is not a viable solution. Now, related topic is how to select motor for various practical applications. And a couple of slides are there in this PPT that address that issue. First of all, you will look at the nature of the electric supply, whether it's AC or DC, and in case of AC, is it single phase or three phase. Based on that, the choice of motor will be obvious. DC motors are generally more expensive than AC motors, assuming same output power approximately. The nature of load also is one factor based on which motor selection is made. Is the load continuous? Is it intermittent? Sometimes very small load, sometimes very large load. Depending on that, the motor selection will be affected. Starting characteristics. Do you need large starting torque? In that case, DC series motor is the best. If you don't need large starting torque, then shunt DC motor will do the job also. Speed control, how easy it is. So when you look at several motor options, you will ask these questions before selecting one of them. Braking. If the motor is running at full speed and you want to brake it, how fast can you or how easily can you do that? There are times when you may have to brake the motor, not BREAK, BRAKE, to reduce the speed, etc. Is the motor noisy? If yes, how noisy? Would it disturb everybody else? That's another question we ask in selecting motors. Does the motor need cooling or heating during full operation? Can it handle overload? How does it look? Is it too big? Is it odd looking, or is it very well designed from cosmetic point of view? And of course, the biggest factor is cost. Industry runs keeping cost in mind all the time, besides engineering aspects, of course. So these are the questions you'll ask. Now, drives can be broadly divided into three categories: group drives, individual drives, and multi-motor drives. Okay. Sometimes combinations may also be there, depending on the application. Group drive, we are talking about industry here. At home, you don't see all this most of the time. Group drive essentially means there is a single large motor driving several machines in the factory. On the same floor, there may be 20 machines, and all of them are connected primarily to one motor through several shafts and through several speed changing mechanisms if necessary. Okay, so pulleys and conveyor belts are used to transmit motion from the single motor to various machines in the factory. One disadvantage of this approach is that if your motor breaks, then everything stops. But still, it has a lot of advantages as well. They are mentioned right here. You need to buy only one motor compared to, let's say, buying one motor for each of the machines, which may require 20 motors. So it is cheaper generally to have one large motor rather than 20 different motors, 20 different small motors. And it is easy to get several speeds because each machine will run at a different speed, generally speaking. So you can use the main motor speed and then use pulleys and chains, okay, to pulleys and conveyor belts actually to get various speeds that you need for various machines. Controlling each machine becomes a little more difficult. That's one of the disadvantages, but still we can manage it. Efficiency is lower, especially if not all the machines are running, because then you are not using the main motor fully. Generally, if you want to add a new machine in the system, it's not that easy because the motor was installed keeping in mind a certain amount of machines. Flexibility is not that much in general. There may be possibility to add one or two more machines, but not more than that. And one big disadvantage is that if your motor fails, then everything stops in the factory. So group drive has pros and cons. It is also known as line shaft drive. A big shaft runs through the factory, and from there several different speeds are derived. Individual drive, where you have one motor for each machine, it has its own appeal. It is more expensive in general, but it is more appealing from operational point of view. Special tools are there even in your workshop. There are special tools, So usually each tool has its own motor attached to it. Installation is easier because you don't have to worry too much about converting speed from one machine to another. Each machine has a dedicated motor. And if one motor fails, all the other machines will keep going at least. That is one big advantage. Each machine can be optimized to get the best performance out of it, which is not that easy if you have only one speed input for all the machines. It is easy to relocate machines from one part of the factory to another if the machine has its own motor. Okay. Disadvantage, of course, is that cost is in general higher because you have a motor for each of the machines. Now, the third variety is multi-motor drive. Even for the same machine, for different operations, you may need a different drive, especially things like cranes, where crane has to move first. For that, you need one drive. Crane's arm has to move near the object that it wants to pick. For that, you need another drive. Picking operation and putting the stuff back to where it was supposed to be, that may need a third drive. So multi-motor, in this case, you will need more than one motor to run even one machine. There are applications like cranes where this is the way to go because of practical reasons. One motor will not be able to do everything. In some cases, you will need large starting torque. In some cases, you will not. So choice of motor will also be different depending on which part of the operation you are looking at. Okay. Some popular information about selection of motors versus the application. I've been talking about it in several different lectures, but here is a summary once again. Series wound DC motor has large starting torque. So electric locomotives are one obvious example for them. Cranes and hoists, they also need generally large starting torque. So DC series wound motor is a very good candidate for them. For line shafts, lathes machines, vacuum cleaners, woodworking machines, etc., shunt wound DC motor is better because it generally can give you a reasonably constant speed. And it doesn't have too much starting torque, which you don't need for these applications. Elevators generally use shunt wound DC motors. Okay, the reasons are obvious, or it can be a compound wound also. If you want large starting torque, then you may have a combination of series wound and shunt wound case, which is called compound wound. So elevators need some initial starting torque, which should be large, but not very large, like in locomotives. So maybe a compound wound DC motor is an ideal solution for an elevator. But once the elevator has started, it has to go at a constant speed. So shunt wound motor would be fine during normal operation, except in the starting. Conveyors, grinders, printing press, they use shunt wound DC motor because constant speed is the requirement. Medium torque is enough for these applications. Sugar mills use induction motors, the AC motors, because they cannot use synchronous motors because synchronous motors run only at one speed. Induction motors can be made to run at several speeds. And sugar mills do not need very high starting torque. Typically, it is seen that induction motors serve very well in sugar mills, even in textile mills. Cement mills, paper mills, again, they use induction motor or synchronous motor. If a constant speed is enough, then maybe synchronous motor would do the job. This is a research topic by itself, which motor to use in what application. There are hundreds of research papers coming out every year. This is called Industrial Management Engineering, IME. As mechanical engineers, part of your job will be selection of motors for various applications. Rolling mills, recommended is compound wound DC motor because it gives high torque and variable speed. Compressors use compound wound DC motor because of high starting torque and variable speed. I took this info from several sources, so I'm not pointing to sources. More information, circular Sawge, compound wound DC motor. You see, compound wound or series wound DC motor or shunt wound DC motor, they are very practical for industry. DC motors are very popular in industry, although DC generators have almost gone away by now. But DC motors are going to stay for a long time. Air compressors and DC generators may need some DC motor to get them going. So this is where we are saying three-phase synchronous motor may do the job. If you're using a DC generator somewhere, it is best to use a synchronous motor because that generator generally has to be run at a constant speed. Many more examples here for your future reference. Clocks, they need constant speed to maintain accuracy in timing. So single-phase synchronous motor will be the best. Because three-phase input to a clock is not generally done. Stepper motor, I told you in the past also, it doesn't run continuously. It moves through small angle depending on the input. If input is an electrical signal which is pulse, that means some signal for some time, then no signal for some time, then signal for some time, and so on. Then motor would move through, let's say 1 or 2 degrees, then it will do nothing until the next pulse comes in. This is called stepper motor. In printers and fax machines, this motor is used. Okay. So this is all about drive. One more PPT, although it doesn't have much more info, but let me show it to you anyway, for the sake of completeness. Then we'll be done. Okay. I'm not the author of this one. I took it from somewhere, but it has some info which is very interesting. This is the formal definition for drives once again. Drives can be mechanical also. This is the point, that's what I'm trying to tell you. But electric drives have taken over by and large. We have seen this kind of flow diagram in the previous PPT also. So just keep it with you. This diagram has some information which is similar to what we saw in the previous PPT. This block diagram is very similar to what I showed you in the previous PPT. Only thing is rectangles are not there. Fine. And drives can be AC and DC for sure. There are advantages of AC drives, and I suppose some disadvantages also. So it's good to have this PPT also with you for future. Okay, this diagram has basically the same block diagram that we have seen in other PPTs. This research area requires people from mechanical engineering, from electrical engineering, from even control, even from computer science, because automation is there. Coding is a must to get all this done. Okay, this is a word called chopper, which essentially means power modulator. It takes the three-phase input and produces a desired AC output. Don't worry too much about it, just know the name for this converter, which is in industry known as chopper. Okay, we have seen all this, which motor has what varieties. Right? Power sources are DC or AC, batteries, fuel cell, that means solar cell, or AC single phase. We have seen all this. So I'm just going to complete this block diagram. We have seen it several times already. Okay, chopper is the circuit that controls the input to the motor. Takes the input from the source and modulates it to get the best possible input to the